All right, unleashing data for HPC and AI, Derek Burke.
Okay, thank you, Brian. I'm both surprised and delighted that I managed to get 15 minutes on the agenda, so thanks to Brian and Mark for arranging that. My name is Derek Burke. I'm from Weka. We have removed the I.O. We're now calling ourselves Weka, the data platform. I'll explain a little bit about why we're calling ourselves a data platform and what that means. And try and move this forward. Things usually work when you stand up, so I'm glad to see you standing up.
Where's the cursor? There we go.
Okay.
Cool.
All right, so a data platform. What is a data platform? The reason we call ourselves a data platform is really to distinguish Weka from traditional storage solutions and storage appliances that I'm sure you're all familiar with. The Weka data platform is built on our high-performance parallel file system that is fully software-defined that we call Weka FS. And the reason we call it a data platform is for a few reasons. One is that we give ubiquitous data access to the same data in the same system. So through NFS, SMB, POSIX, S3, GPU Direct, we've even got a Kubernetes CSI plugin as well. One of the other reasons is that Weka is completely software defined. It's deployed in containers. You can run exactly the same Weka binary, same features and functionality on premise or in the public cloud, and I'll talk a little bit about how we do that. We can scale up to 14 exabytes in a single shared namespace, and we have performance for very diverse I/O workloads without any tuning required, and I'll talk a little bit about how we achieve that. And lastly, we've got class-leading economics through the ability to automatically tier data into tiers with spinning disk from tiers with flash, and present all that as a single shared namespace. But we also have built-in backup and disaster recovery without the need to replicate data. So total cost of ownership with a Weka solution can be fantastic. Just to kind of stamp our credibility, these are generally the types of markets, the types of use cases where customers are using Weka today. In finance in the UK, we've got several proprietary trading firms that use Weka, a national bank as well. In life sciences, one of our largest customers is Genomics England. They have an 87.6 petabytes Weka namespace here in the UK. We've actually just got another bioinformatics institute in the UK deploying a 50 petabyte Weka namespace at the moment as well. We've got 2 major pharmaceuticals here, many other life sciences customers across the globe. Done very well in the media space, predominantly around post-production. AI machine learning, we've got about 12 autonomous vehicle customers across the globe, predominantly using Weka to feed their GPU-based systems for training, etc. Also customers that are using AI for medical images, for finding anomalies in components before they leave their factory, all that kind of stuff. And then in traditional HPC, we've got customers in the MOD in the UK. We've also got customers like University of Surrey. They have a new AI cluster that they're using Weka for. And then in oil and gas manufacturing, where you'd expect to see scientific and technical computing. So, moving to a bit more of technical detail about Weka. This is how Weka is deployed in a production environment. So all of our customers have commodity NVMe servers. These are just Intel or AMD-based servers with NVMe devices inside. They can be on-premise with any of our server vendor partners. We've got reference architectures today, I'll try and remember them all, with Dell, Lenovo, HPE, Supermicro, Hitachi Vantara, and others. We can also use NVMe servers or instances or shapes or whatever you call them in the public cloud. Okay, so these could be in the public cloud. We come along and we add the Weka software to these NVMe servers. It's deployed onto the NVMe servers in standard LXC containers, and it creates from those NVMe servers a very, very fast shared storage system. So we've now got an all-flash network-attached storage system, parallel storage cluster that's extremely fast. If I was to compare Weka in terms of performance density versus a similar all-flash Lustre or GPFS cluster, we're probably fairly similar in throughput performance, but where Weka really stands head and shoulders above in performance density is IOPS and metadata performance. And we're probably in the range of an order of magnitude faster than those comparable products. Excuse me, pressing the wrong button here. Your compute clients and applications would generally access the data on the Weka storage cluster using our POSIX client interface. It's lightning fast. So we did some testing with an NVIDIA DGX A100, and we showed 162 gigabytes per second of throughput and 1 million IOPS delivered to that single compute system. Our latency is very, very low. So for 1 meg IOs, we're sub-millisecond. For 4K IOs, we're 100 to 200 microseconds latency. The reason our latency is so good is that the Weka POSIX client interface lives in user space and leverages a library called DPDK to basically avoid the kernel for IO operations and communicate directly over the network to the storage cluster. What we're actually doing is we're taking your files, we're splitting those into 4K shards, and we're distributing those across multiple network links across all the NVMe devices in the storage cluster. We're then protecting that data with our own erasure coding-like algorithms. They start at 3+2 and go all the way up to 16+2. They're actually set at the number of servers you have. And if you have over 18 servers, we would still use 16+2. We can also go up to +4 parity for very, very large clusters to give them even more resiliency.
So what does that cost you in performance?
What does it cost us in performance?
What kind of hit do you get with that?
Yeah, it's a good question. Weka is extremely fast.
Those performances quoted with or without the erasure?
Oh no, the erasure coding's always on. Yes, sorry Paul, I misunderstood. The erasure coding's always on. You can't use Weka without data protection. Yeah.
A lot of the things we do,
Yeah.
when we quote high performance, we handle that off.
Yes.
Because the system put it on.
Yeah.
We lose a lot of performance, that's why I asked.
It's a good question. Any performance numbers you see with Weka, the data protection's on. Yeah.
There's lots of benefits from it.
All right. Thanks for clarifying that. Cool. There's also, we do something very, very different with metadata than you're probably used to. And we also store the metadata on the NVMe devices, and we also protect it with our erasure coding. But running on each one of your NVMe servers, we have what we call virtual metadata managers. Now there's dozens of these running on each NVMe server. They're not tied to the underlying namespace structure, so they're not tied to a particular file system or directory or subdirectory. What that means is we've completely removed the metadata bottleneck that you get in traditional parallel file systems. So you can, with Weka, have billions of files in a single flat directory and still get fantastic performance. That's why we're doing very, very well in areas that have mixed I/O or areas that have lots of small files. So think about bioinformatics, think about algorithmic trading, think about a lot of modern analytics and AI environments. I was shown just one compute client there, but our customers generally have tens, hundreds, thousands of compute clients. I think our largest customer has 15,000 GPUs in their cluster, all concurrently, reading and writing data to the Weka storage cluster. Doesn't matter to us if they are bare metal Linux, if they are virtualized with OpenStack or VMware, if they're containerized with Docker, Kubernetes. They can all use our POSIX client interface for lightning fast access to the data. But we also support, as I said before, NFS, SMB, and S3 access to the same data, which is really important because if you're ingesting data from a scientific instrument via SMB, but you're processing on POSIX, with Weka you can do that very easily because both protocols and different clients have access to the same data. Scaling your Weka NVMe cluster is super easy. You just add more drives or more servers into the namespace. Weka will bring those in and automatically distribute your data across the larger cluster in the background to always maintain a balanced system. Now, some of our customers have tens of terabytes of data, some of them have tens of petabytes. Generally, they don't want to keep tens of petabytes on NVMe. We do have some that do, but generally they don't want to keep tens of petabytes on NVMe. So we give them the option to add a secondary tier based on object storage. And we communicate between both tiers using the S3 protocol. The metadata always resides on your NVMe tier, always remains lightning fast. Within your Weka namespace, whether you have one or two tiers, you can have up to 1,024 what we call virtual file systems. You can set up different features at the virtual file system level. You can say, I want this virtual file system to be completely encrypted. I want it to use your snapshots. I want it to tier into object storage. At that point, you allocate a bucket from your object storage to that virtual file system. You set your policies that dictate when the data becomes colder, it gets moved into the object storage. And Weka will do that movement automatically. All writes land on the NVMe tier. Any reads of data that are in the object store, Weka fetches them back, puts them back on the NVMe tier and serves them to your clients and applications. The data will then remain on the NVMe tier until the policies dictate that it gets moved back down. And again, everything is automatic, presented as a single shared namespace. I mentioned Genomics England. Actually, one of the interesting things about them is that they hold the UK's 100,000 genomes data set. Now that data set, every month they read about 50% of that data, right? It's about 20 petabytes in size. Every month they read about 50%. Every 3 months they read about 85% of the files. I said of the data, it's of the files. But they only touch on average 10% of each of those files. Now, Weka can do byte range reads from the object store, so we don't have to bring back whole files. So what we're enabling them to do is actually to have high performance with a fairly small NVMe tier, because we don't have to bring everything back onto the NVMe tier if they don't need it, right? So we're extremely efficient in the way they can manage data. I see I'm pretty close to the end of the time here. I'm just going to wrap up by giving you an example of how some of our customers use Weka, because it's extremely flexible. A lot of our customers today are allocating a bucket from their object storage to the Weka NVM, to a virtual file system, and they're tiering automatically into that bucket. They'll then attach another bucket to the same file system, and they're pushing our snapshots into that bucket. Our snapshots can be bundled with the metadata for a file system and used for hierarchical backups, for disaster recovery, for cloud bursting. And we have lots of customers that have a bucket in one data center, maybe a bucket in another, or even a bucket in the public cloud. We're giving you real flexibility in how you protect your data, and we're also giving you the ability to leverage the resiliency of an object store to protect data at very, very high levels without having to replicate it. So you can imagine object store, geo-distributed, 16 nines, availability. These things are massively protected. And then you leverage Weka's snapshots and snap-to-object capabilities to protect that data. We're giving HPC users the ability to protect huge amounts of very active data extremely efficiently. And it's very, very hard to find. Okay, I think I'm probably at the end. I could bang on all day, but I'll stop. Okay, thank you very much.